Right, let's have a go at 5. It says, given that the quadratic equation 3k minus 2 lots of x squared plus 8x plus k equals 0 has no real roots, show that this inequality holds. 3k squared minus 2k minus 16 is greater than 0, and find the range of values of k satisfying this inequality. So I've written down the question then. Here's our quadratic, has no real roots. Well, we know the discriminant, b squared minus 4ac, for it to have no real roots must be negative. So here, b squared minus 4ac must be less than 0. So b is the number of x terms, that's 8 as b. Here's a, so I'll circle it there, and here's c. So let's put it into this inequality. B squared is 8, 8 squared is 64, so I'll just write 64 minus 4 lots of a, which is 3k minus 2, times c, which is k. And that needs to be less than 0. So let's just tidy it up. We get 64. Expand the bracket, minus 12k. Minus times minus is a plus. So you've got 8. B squared minus 4ac. Yeah, that's right. 12k times a k, so you've got k squared, haven't you? Because there's a k there. And then you've got plus 8 times k. That's it, nearly lost a k there, didn't we? Or didn't I? Right, there we go. That's that. So now let's times through by minus 1 and flip the inequality around. So that becomes, I'll write that one down first, and it becomes plus 12k squared. This one becomes minus 8k. This flips to minus 64, and we flip this around, don't we, as greater than 0. So that's it. That's what we wanted to show, hopefully. Yep, I think we're okay there, but we're nearly there because there's a common factor, isn't there? There's a 4 common all the way through, so divide by 4 all the way through, and that will give us the answer, won't it? 3 of these. Divide by 4 here, minus 2k. Divide by 4, minus 16 is greater than 0. Okay, so what values of k now? Find the range of values of k satisfying this inequality. So here's the inequality. So let's have a little look at that then. So we should be able to factorize that, shouldn't we? Hopefully. It's going to be 3k and k if we can. And it's either 8 2s. Yeah, 8 2s, because 8 1s are 8 and 2 3s are 6. And the difference between 8 and 6 is 2. So I reckon 8 2s, and it's got to go here and here, hasn't it? To be the 3. No, the other way around. No, that's right. 8 and 2 goes there. So now it's going to be 6 and 8, but we've got a minus, so that needs to be a minus, and that needs to be a plus, greater than 0. So let's just check it. 3k squared, yeah, that's fine. Plus 6k, minus 8k is minus 2k, and then minus times plus is a minus, 8 2s are 16. Okay, so we've got a quadratic in k. It's a U-shaped curve, and these are the roots. So here you can see this equals 0 when k is minus 2. So a little sketch in our mind's eye. That equals 0 when it's minus 2. This equals 0 when this is 8/3, isn't it? Which is 2 and 2/3. So 8/3 goes over here. And you can see that this quadratic is going to look, it's a U-shaped curve because 3 is positive. So this quadratic in k just comes up and goes like so. I've done it with a dashed line because it's easier for me to draw. Okay, so that's what we've got here. So from this then, so we can see that for this to be greater than 0, k can be greater, it can't equal 8/3, or k needs to be less than, it cannot be equal to because it would equal 0 then, it must be less than minus 2. Okay then, that's 5 done. Great.